I am so
Hello.
excited for this. I actually had to beg these gentlemen to come and do an Ask Me Anything this year.
We were like,
They didn't
fine.
even submit one. Welcome, Trey Grainger and Doug Turnbull. Would you like to do a short intro, or would you like to start answering questions?
Yeah, I mean, I'm Doug. I've done some form of search since 2013, and I still haven't found what I'm looking for. I'm known from such books as Relevant Search and AI-powered search now, and I don't know, I think people know me here pretty well.
I'm Trey Grainger, the co-author with Doug and Max Irwin, who's not here today, but sends his regards. I've been working in search for most of my career. Currently, I'm the founder of Search Kernel, a company that does AI-powered search consulting. I also am a technical advisor with Open Source Connections, and I've done a lot of interesting stuff as CTO, head of engineering, chief algorithms officer of various search companies over the years. So we're excited to be here. We've got our new book, AI-powered search, that just came out the last couple of months. Many of you have a copy. We are doing a book signing at 1 o'clock. If anybody wants to come by upstairs, happy to chat with you. We're giving away a few copies of the book. We already have given a few away today. We'll give one away to maybe the best question from this session. Don't make me choose, though. Maybe David can choose. I don't know. Yeah, we're excited. This can be a little bit of a ask me anything if there's questions you want to kind of dive into. A little bit of a stump the chump. Try to challenge us with something. It won't be hard, I promise, to stump us. But yeah, we'll get going. That's probably good. So happy to take some questions.
Okay, and for the online folks, we are aware that the visual of Doug and Trey is not actually showing up in the Zoom right at the moment. And I'll take the first one to get near me with a question for...
Good morning. Thanks so much for coming. What was the single most important piece of information, piece of user behavior in terms of improving relevance before AI? And then what is the single most important piece of information, user behavior information, to collect after AI? And if it's different, why did it change?
Do you want to take that one first, or you?
I could take this question lots of different directions. One thing I think that's interesting about AI is now that we have RAG applications, it used to be the fact that, like, and John Berryman was asking me, like, what all have you learned? I've been out of search and I'm getting back into search. What all have you learned? I'm like, well, I learned a lot of stuff about aggregating clickstream data into relevance, judgments and that kind of thing. And as you look at, and totally that's before AI and totally valuable. There's, like, you can, as a keyword you can search on, there's click models. We write about it in the book. Now it feels like when you get to RAG and people building RAG applications, you're going to see a single chat. Everything is long tail. You're going to see a single chat. It's getting clickstream data aggregated in some way is a new and different challenge. Like, how do we interpret a conversational systems clickstream data to really pull in, and this is especially true in e-commerce where I've done a lot of work at Daydream, and actually also very true in social media and just all over the place. Everyone's focused on human evaluation, LLM as a judge, which is perfectly fine, probably because we're all building, maybe not all of us, but many of us are building or supporting AI startups that maybe haven't seen a lot of clickstream data. But I do feel like there's how do you take and aggregate clickstream data and that kind of sort of like click model feedback to get the subtle things that people aren't obvious when you're doing ratings, to feed that back into our RAG systems. I think that's an unsolved problem. I mean, I have some ideas, but to me, that's not the single most important thing since AI. I mean, obviously there's LLM as a judge and everything, but to me, like, the big interesting thing is, like, how do we get back to that learning from user behavior aspect that we have in search applications, because we see a million people searching for red shoes, so we can see what's relevant for that. We see one person asking a very specific question once a month, so we can't really infer much from that clickstream data.
So I don't know where John went, who asked the question. There he is. All right. So I'm going to challenge your question slightly, only in the sense that you said, before and after AI. And I assume by that you mean the current generative AI, rise. But I would argue that, technically speaking, going back decades and decades, AI is just allowing the system to act kind of human, to behave intelligently. I personally do a lot with clickstream data, so user queries, clicks, purchases, etc. The specific data points and those signals that are the most important depend on the domain. If it's e-commerce, it's usually the purchase is the most important, then maybe the add to cart, then the etc. But in totality, it's really about collecting the full stream of data and being able to better understand the user and their intent, and their what they're interested in, what similar groups are interested in. So the individual most important piece of data on any particular user might vary, but I would typically say the most important data to collect is the first piece. Meaning, if somebody comes to your website and you don't know anything about them, you can run a lexical search, you can run an embedding-based search, but you can't use the user's actual intent or any understanding of the user in that query if you know nothing about them. But the reality is, if you have a website and somebody comes to it, you pretty much immediately know something about them. You know their IP address, which gives you some indication of their location, unless they're on a VPN, which gives you some indication of maybe their nationality, and you can make some generalizations based upon that about certain things to boost up or down based upon that location. Then the first time they type in a keyword, we know something about something they're interested in. Maybe it's only for that session, or maybe it's something that you can look at across sessions and then start to build an understanding. So I think we have a tendency in data science to say we need lots of data. We need to process every piece of data before we can come to some meaningful understanding about a person. Kind of to some degree, even with documents, we have the cold start problem. We kind of have that with users as well. But my point is, from the very first interaction, you have some information about the user. And every subsequent action helps you build a more robust understanding of them and their profile and their intent that you can then use to help cater the results to them. So I would say the most important piece is the first piece, only because you need to get started and you need to use user behavior data. Most people don't. Most people just use lexical, keyword-based stuff or embeddings and just completely ignore the user behavior side of things. I would say get started, start collecting, use what you have, and then as you collect more and get more sophisticated, there's all sorts of crazy models you can build. I personally like to do matrix factorization, sort of like the steps to get to collaborative filtering, and use the factored matrices as behavioral-based embeddings to then pair those with text-based embeddings and image-based embeddings and all of those modalities, because you can actually find interesting relationships between behavior and attributes that are in documents. So there's a lot you can do, but the most important piece is just getting started, so the first piece.
Thank you, David. I think John kind of stole my first question. I have two questions. I'm going to still rephrase my first question. So most of the Gen AI bubble busted 2022, 23. I read your first initial edition in 2023. So I'm wondering how your thought process have changed in the last 2 years. So if it's probably the same answer as what you just gave to John, that's fine. So the second question is, we are working with a lot of public sector and financial services, and we see the document sizes vary from like a single page, 2 page, 10 KB, 20 KB documents, all the way till 100 MB, 1000, 2000 page. And most often chunking becomes a key strategy for improved relevance, but that creates a lot of noise by duplicates, and semantic highlighting is still pretty poor in most products. So what is your recommendation for ideal chunking? I know you've addressed that in your book, Trey. We also spoke about that in the workshop. But for these extreme conditions, how do you sample? How do you do relevancy testing? How do you compare what should be the metrics? And how do you dedupe? That's pretty much my second question. Thank you.
Okay, on the first question, in terms of how thinking has changed since we started the book to the end, I would say a lot of new things, new techniques evolved. While the book was in process, there was one point when the book was almost finished, where we added a year to it, to writing it, because things were changing so drastically, particularly with regard to Gen AI. There's one point where I wasn't really talking about quantization much because nobody was talking about it much, but it's in there. All the different techniques. Chapter 15, the last chapter, went from a fairly short chapter to a very long chapter, and chapter 13 as well, which is about embeddings and semantic search and quantization and all of those things. So I do think now, and this is something we didn't actually get into in the book, we did leverage LLMs, we talked about RAG, but we didn't get to LLMs as a judge other than just mentioning it's possible. And I think that there's a lot in terms of integrating LLMs, very fast, efficient LLMs at lots of different places in your stack to do things. I'm going to hand this one over to Doug because I know he's got some stuff to say on this, and then I want to answer the chunking one as well. But let me flip over to Doug for a second.
Yeah, when Trey said he was writing the book, I think it was at Haystack. He told me at Haystack 2018. Yeah, 19 maybe. And then, of course, we had a pandemic. And then, of course, I think you said you wanted to write it in 6 months in 2019. Oh, sure yeah. But the the most important thing that happened is ChatGPT came out in 2022, and the word AI morphed into meaning generative AI. And we had to somehow, it's funny because when we talked about the book originally, it was very much machine learning is timeless. It's all math. Like all these things, they, live forever, and these techniques, some will live forever. And that's honestly true in search. Like, I don't know of many search techniques that have just died and no one uses them anymore. A lot of things do and can work. But now it's like, oh, there's AI in your book and you have to somehow address these things. So that was probably, that was a huge challenge. For the LLM stuff, I think if we had kept going or written the second half of the book, like I mean, I've said this enough. I'm teaching a course called Cheating at Search on LLMs this summer, and I think to me, I think we all need to be switching to an LLM first mindset when it comes to things like query understanding, when it comes to things like content understanding. There's a whole generation of AI engineers that spend 80% of their time prompt engineering and not really building ML models like maybe we did a couple years ago. And with faster LLMs, with the ability to cache LLM, pre-compute LLM responses, it's just becoming the default. We just need to start with this assumption and not oh, maybe I have this old solution, I'll layer in one or two things. I think it's sort of, that to me would be, if we were to start from scratch today, maybe a different orientation that we might take on the book. Now, the stuff I said before about, I feel like the blind spot in all this, one big blind spot, is actually the user clickstream data. And because now especially in RAG, everything is a long tail query. How do you solve search when everything is on the long tail is an interesting problem. But to me, that's the big one. I'll let Trey talk about chunking, since I know it's something he's interested in.
Yep. And I will say that in the book, most of the techniques are still valid and useful. Obviously, it just came out, but there's things that LLMs can do now that replace some of the old techniques. For example, there's a knowledge graph learning chapter, and in that chapter, we actually go through algorithms to extract out concepts and relationships and things like that. You could probably just give that to an LLM today and get about 90% as good, in some cases better. It won't be as you'll have a lot more noise and false positives in there, but it's way easier to do. So there's certain techniques that most people just won't do anymore because it's easier with LLMs. But yeah, generally speaking, all the techniques that built up to this point are still useful, and if you combine them with LLMs, you tend to get good results. And I'll also say on the behavioral user behavior based algorithms, about a third of the book is actually on using user behaviors, queries, click streams, queries, purchases, those kinds of things, and then using that to learn semantic data, so misspellings people commonly type in, related terms, acronyms from query logs, generating personalized search recommendations, and behavior-based embeddings for users that you can use to boost things up and down, and leveraging lots of other reflected intelligence techniques. So we can talk more about that if people have questions. But on chunking, the second question. Personally, I am not a huge fan of most chunking techniques that are used today. Most of them have kind of come from the RAG community, and there's all this category of naive chunking where you just you split on words, you split on a certain number of characters, you split on sentences, you do semantic chunking, you do contextual chunking, you do adaptive chunking where you're going through and figuring out lots of ways to do it. There's the problem with doing chunking, as we all know, is you're taking some text and you're splitting it up. I would say arbitrarily splitting up, but depending on the algorithm, it's not necessarily arbitrary, but from the context of understanding and grouping text together that belongs together. In some ways, your entire document belongs together, or it wouldn't be a document, right? Your sentence belongs together, it wouldn't be a sentence. Your paragraphs belong together, they wouldn't be paragraphs. And so in the book, we spend very little time on chunking, and basically just give this disclaimer that most of the current chunking strategies, in my opinion, will go away over time. They're sort of shortcuts to get us to a better ability to represent documents and parts of documents in a vector database or a search engine, right? I am a huge fan of things like, if you're going to do chunking, doing something like late chunking, where instead of pre-chunking the text before it goes in the engine and then generating a bunch of embeddings and putting them in, you generate the embeddings first, like on a per term basis, and then you sort of group the embeddings together based upon how related they are. So that's called late chunking. I'm also a huge fan of late interaction models. And so things like Colbert, Colpally, those type of models where way back in when did Word2Vec come out? 2012? 2019? No, Word2Vec. 2013, 2012? 2012, 2013. Whenever Word2Vec came out, it was amazing because all of a sudden we were taking text and we were saying, wow, I can turn this into vector. We didn't even call them embeddings at the point, I don't think. I can turn this into a vector that represents the meaning. And it was beautiful, and we did it on a per term basis. But the downside was each term had a meaning coming from the model that was pre-generated, and it wasn't contextual. So I couldn't take a sentence and say, well, the word, this word means something different based upon the context of the rest of the sentence. When we got to 2017 with transformers and 2018 with BERT, we kind of flipped the model because now all of a sudden we had attention, we had context, we could contextualize the meaning of each term. And so at that point, we started doing that, but we would do it for entire documents. I take an entire document, get an embedding for the document, and the embedding is basically kind of an average of all the terms, all the tokens in the document. And so we got a general understanding of the document. But then if we wanted to get more specific, we had to break the document apart into terms and sentences and paragraphs in order to better represent the meaning of those things. And this is where sort of the reason for chunking is because I've determined that there's valuable meaning in the pieces, and I don't want to deal with just the abstract, sort of the general document, and I don't want to deal with just the specific, sentences. When you do something like late interaction models, we basically go back to what we did in 2012, 2013 with Word2Vec, which is every word gets its own embedding. But the embedding is based upon that word's meaning and the context of all the other words. So we use attention to generate a per word embedding where if you sort of take all of the words in a sentence, they're all contextualized with each other. So in aggregate, that sentence and all of those embeddings represents more faithfully the meaning of the sentence versus just taking the whole sentence and leveraging it. And so when you look at the relevance scores that you get back using something like Colbert or Colpally for images, they blow away BM25 and all of the other techniques that we're using for chunking these models. So there's lots of ways to do it. The downside of the late interaction models is every single term in every single document ends up having an embedding, so you blow out the amount of storage you need. There's ways to prune and get that back down a bit, but long story short, my answer on chunking is most of the techniques that we talk about, like thousands of them I've seen, are pretty naive, and I don't recommend them if you don't have to use them. So I would much rather see a future where things like late chunking and late interaction take over. That's my answer. I don't know, Doug, if you have a variation on that.
I think for a long time in search, I think just a quick part of that is if and Matt Overstreet and I actually worked on a project with O'Reilly Media. One incarnation of Safari. This is pre anything, pre AI. And really, just to get BM25 to work well, we took books and we sort of chunked them into section blog posts length articles. So I do think there's value in traditional search, even of like breaking things up into things that are reasonable units of search. But yeah, I think Trey's point about like chunking like down to sentences and stuff is a completely different animal.
And from the Zoom, following on to what you just said about chunking, any thoughts on Colbert v2 multivector for retrieval? Would you like to add anything more?
Do you want to add anything?
I kind of answered that, but it's awesome. Use it. It works well.
Yeah, I don't have anything to add. What he said.
So I have many questions, but I'll try to stick with the most specific one. So one of the main challenges we're dealing with in our semantic search index is like both latent. So the two main challenges are latency and storage space. So the places we're starting to look are implementing like matryoshka representations as well as quantization. And I'm curious if you have any thoughts on like trade-offs between or performance to latency trade-offs between like reduction in dimension paired with quantization, and if you have any advice on how to go about trying that other than just see what works best.
Yeah, I mean, I was going to say see what works best. I think like it's going to be very dependent on the vector space and the embeddings you're using. I also think an underrated thing, getting back to clickstream data when it comes to embeddings, in traditional search, there is a whole field of doing like two-tower models to make embeddings a lot more effective. And when you make your embeddings a more effective first pass retrieval, then when you go to shrink them or dimensionally reduce them, it's just going to be even better. So, I mean, it's not going to be even better. It's going to be better than if you just shrunk the original embedding. So I think that's an important consideration.
Yeah, and I was going to say, personally, I've played with Matryoshka representation learning embeddings, and I've done all sorts of quantization AN. My general take, at least from the models I've used, I'm not going to state the name of them because I don't want to embarrass anybody, but the quality that like the recall you get when you leverage MRL, to me it's not really worth the trade-offs. Like I would rather just use like whatever int 8 or 4 or binary or whatever. I tend to find that when you just quantize and use the quantized version, with re-ranking and what have you, you get better recall than if you try to use Matryoshka and just use parts of the embedding. So I think it's neat as an idea, but in practice, I don't think it's actually, usually the trade-offs aren't there for making it worthwhile for using it.
Thank you.
And from online, David asks, at our e-commerce company, we get some very general search queries, 10,000 or more semantically relevant results. How can we make sure that the KNN retrieves the subset that users are most likely to actually buy? And do you take Venmo for this consultation?
Yes. Apparently we take Stripe.
Do you want to phone a friend on this one?
Yeah, let's phone a friend.
We're going to phone a friend on this one. This is a good question. Hold on 1 second. I'm gonna
We give up. We're just going to...
For those of you who are actually old enough to remember,
Yeah, we're old.
phone a friend is the most important lifeline.
Do we get we get $1 million after this, right?
We have to wonder which friend they're phoning. I will repeat the question after they get the phone.
Buddy,
friend on line.
hey, I'm in a big auditorium, and we're being asked some questions that are hard. I was curious if you might want to take one that's related to the book.
It's Sam Altman.
Oh, good.
Okay. All right. Hey guys, this is Matt Irwin, our other co-author.
Thank you, Matt.
Hey, can I try to throw you up on the screen? You want to say hi? All right, one second.
All right.
See if you can answer while I'm getting them.
I want to reread the question for everyone's benefit now that Max
go
is
for
here.
it. Yeah.
At our e-commerce company, we get some very general search queries, 10,000 or more semantically relevant results. How can we make sure that KNN retrieves the subset that users are most likely to actually buy?
Yeah, that's a great question. So I think this is actually secretly a diversity of search results question. I told someone I was meeting with someone at Daydream, my company, recently, and the phrase came out of my mouth, and I just sounded so smart that I have to repeat it. It's like, you want to diversify over things you don't know in the information need and do ranking against the things you do know. It's a bit of like hedging. Hey, oh my God, so how do you, I don't think there's really like a single KNN thing that you do. I think if you get a query and you don't know exactly what they want, like they just search for shoes. Well, there's all kinds of types of shoes, right? And there are 100,000 results or a million results. But you want to do in that category is give good representations of different groupings in there, and that could be clusters, that could be literal subcategories of like dress shoes or sneakers or whatever. Because if you just do KNN search, you may just get all sneakers or you may get all dress shoes. And really your goal when you don't know something about the intent is to reduce the likelihood that they're going to not see something they want. You want them to take a next action and refine their query. That's actually a place where refinement and more searching is good. So I think it's like you give them lots of options and then they'll see the results and they'll hopefully take a next step. And that's not just a KNN thing. It's a general search quality thing, in my opinion. Max, you want to give an answer? Oh, you're muted or we can't hear you.
Can you hear me?
Yeah, go for it.
Hey, everybody. So I think I heard the question. So what I've been trying recently, first of all, I assume you mean not just KNN, you're probably doing some sort of hybrid search, right? If you're just doing a raw KNN on items, then switch to hybrid and make use of the text features. The other thing that I'm seeing now is, and I've tried, is newer models let you embed JSON documents, not just like snippets of text. So instead of having something like a name vector and a description vector and your maybe your image, multimodal image embedding, you can actually take an entire document in JSON form. And like modern BERT models are good at this. Certain modern BERT models are good at this. And you can just get the embedding for the entire JSON because the model was trained on JSON documents and JSON similarity where it makes use of the entire structure of the document. So that can help with certain things. The subtlety is hard because that's always a business problem, right? That's like the merchandising idea of, well, we've got this item on sale, we want to boost it, or we have a promotion, things like that. So you can certainly add those signals to a hybrid search and maybe even try adding that signal into the JSON document that you're embedding, but you have to train, you'd have to fine tune the model for that type of behavior, which, is hard. But there are a lot of teams fine tuning embedding models now. If you're getting your embeddings from somewhere like OpenAI or something like that, it's not going to be great because it's going to be very generic. So you want to have a purpose-built model that you're working with for your own products. And I think that would help a lot with what you're doing. I'll also mention, I don't know the name of the model, but I read a paper a couple days ago by Pinterest where they were doing a two-tower model where they were doing really interesting stuff with combining a lot of different features into the same embedding. And the features were like product information, user information, rating information, context information, image information. So there's a whole bunch of signals that they were trying, and they got really good results. So I don't have the name of the paper off the top of my head, but just go look for like Pinterest two-tower embedding model, and it'll pop up on Archive or something like that.
Sweet. Maybe. Thank you, Max. By the way, your head is giant on the screen. You look awesome, though.
Ah!
We'll keep you here for a couple more questions, maybe. David?
Thank you for joining us,
cool.
Max.
You get all the authors of AI-powered search today.
Isn't this cool?
All right, I'm next. So it seems like the first generation of RAG applications are about leveraging existing search index that you might have and then using that as context for answer generation. As we're moving more towards systems that are conversational, or you're really trying to extract insights, should we be reprocessing the content in a different way? In other words, customize indexes specifically for generative AI answering, rather than just taking the existing search engine that we have and repurposing it. So thoughts on strategies for re-indexing content optimally for RAG?
Short answer is yes. I'm a big fan of you use the tool you need to get the job done you're doing. And so if you're trying to do a lexical search, you've got fields in your index that you search on with keywords and analyzers, language specific analyzers, that kind of thing. If you're doing embeddings, you obviously have a separate field for that because you can't put that in the original field. Similarly, if you need to represent your documents in different ways to be able to find parts of them, then you don't want to index a giant PDF. Instead, maybe you want to index, like say it was our book, you would index each chapter or maybe each subsection, and then you can relate them back to the ID of the top document. So there's some level of, this gets back to chunking, of breaking things up into meaningful pieces to be able to deal with as context. As we start having these models, these LLMs with large context windows, like we're up to like 10 million in some of the newer models, if you're going to do real-time processing of context, then you can pass a lot in. Caveat being, all of the current models, even when you get far into the context windows, actually do a really bad job of using that much context. So even though you can pass it in, most of the LLMs aren't actually leveraging it super well. I think, personally, it's whatever the task is at hand. If you're trying to, so for example, if you take something like GraphRag, in GraphRag, you're taking documents, you're chunking them however you want, but then as part of that, you're essentially taking all of these sentences or phrases or chunks in the documents, and it's actually taking them and finding the related ones and sort of summarizing them together and making, I think they're called communities, but it's making these sort of representations that aren't actually in your document directly, but that are sort of, it's almost like building a knowledge graph as you go. You're building all these relationships and understandings. So there's things like that which are far away from a traditional document in a search engine, where you just index the text and maybe add some embeddings on certain attributes or summaries of the document. But they allow you to more intelligently sort of traverse the graph of information that is represented not just in one document, but across your entire corpus. So I think the short answer is yes. I think you want to represent things in whatever engine you're using in the way that's going to optimize you getting the best results back to then be able to use as context for the models. But I don't know. Max, do you have any thoughts on this one?
Oh boy. Yeah, a couple thoughts. I don't know if they're going to directly answer the question for you, but one thing I've noticed is that if you're talking about Lucene-based engines like OpenSearch, Elasticsearch, Solr, in terms of embeddings, they haven't really caught up with a lot of the patterns that people want to try and are being used. Like, it's really hard to have a lot of different individual vectors that from a chunked document. If you got a document that's like a couple hundred pages long and you want to chunk it up and make it small, and you want to have a lot of individual vectors, or even if you're doing something like Cole-Pally, where you have a late interaction, we're not seeing a lot of good technology on the Lucene engine-based stuff. yet. I'm hoping, and I know people are working on this, so I'm hoping to see some improvement there. Um, I think the other thing that I mentioned is maybe just a callback to when we were talking about chunking specifically. I personally like the idea of chunking because something that I've been the hill that I will die on with search is that people aren't looking for documents, they're looking for information. So uh, chunking can aid in that process if you know what's going on. When you have to do something like a reindex and try a lot of different chunking strategies, that's certainly painful. So I don't know if I have a good answer there yet with like Lucene based engines. Um, and maybe maybe Vespa is better at something like this. I'm not sure. I haven't tried that out. But I don't know if if what I said is a good answer to your question or not. But you know, I'm hoping that we're going to see better technology to help these problems in the future, I guess is my answer.
Okay.
In a future where LLMs are free, have infinite context, and are real time, do we still need vector search? How would you see the search world changing?
I feel like even with the vectors, the LLMs that have like a million token context, they're not great at paying attention to the entire context. So they tend to still work better with shorter context. So I do think context windows are a bit of a misnomer as a hard limit. It's more of like things get worse as the context size increases. So generally, I think yes, because I think it's going to be perform much better when you give it fewer things to pay attention to. Um, and part of that is because, and I'm curious, I don't know enough about LLMs to answer this question, but my sense is that LLMs are limited by their training data, and we are the training data, and human beings do a pretty poor job at paying attention to instructions. So if that's the training data, how do we actually train models that can pay attention to 10 million tokens or infinite or whatever tokens of instructions? Certainly, if we could guarantee that everything was paid attention to, and there was infinite or whatever memory bound context, we'd have to have an LLM too that could like somehow be sharded because a lot of our data exists in multiple systems. So you'd have to have like, I don't know, infinite RAM sharding LLMs or something. So that's another constraint. But I think I'd wait to see and if we can solve this training problem where human beings are terrible at following instructions and therefore LLMs are as well.
Yeah, I'll take a slightly different approach to this, which is I don't think RAG is going away, which is kind of like part of the underlying question. If the models are large enough, can take in all the context, do we even need search engines in RAG? High level, I think of a search engine as a cache of information. So if you think of like a web search engine like Google, like what do they do? I could have an LLM when I ask it a question that just goes out and crawls the entire internet and finds every page and analyzes it until it finally, like an agent that finally, processes, finds the right information and returns it. But that would take years and years and years and years, decades to actually do that. So instead, we have the model go hit Google or whatever API we're using for web search, and immediately out of all of the billions and billions of pages out there, find the context that is the most relevant to bring back to give to the model. And it takes, tens or hundreds of milliseconds to do that. If you can't pass if context windows are unlimited and you could pass the entire internet in, it would be crazy slow, first of all. Second of all, like Doug mentioned, it wouldn't do as good of a job. So the need to get the right context for the LLM to process is there no matter what. Whether you give the entire internet to the LLM, which isn't possible, or whether you give very specific focused context. But the point of the search engines is to be a cache that returns the most relevant pieces of context needed either for the user to answer their question or for the LLM to answer its question. So I just don't see RAG's just not going to go away. It's a design pattern that's needed for these systems.
I'm gonna make one jump in and answer this last one, and then I got to drop. Um, because I think about the shift that if we just answer the question in its purest form and forget about search for a minute and just talk about LLMs and what's happening with LLMs. The thing that everybody in Soda is trying to figure out now is this problem of catastrophic forgetting, where if you have an existing model that took months and millions of dollars to train and it's huge, and you want to add a little bit like every day, just kind of how we work with search. The problem is if you keep on fine tuning a model with new information, it forgets older stuff, and that's the problem of catastrophic forgetting. So I think that if teams are able to solve this model in the current, working with LLMs, I think there actually needs to be a huge shift in the architecture or a big breakthrough. I think that would change like so many things in the way that we think about how models are used to return information. Like right now, it's like this static thing and it's very versioned, and we have to use the search engine. I don't think that maybe replacing the search engine is a thing, but I think that if you get to the point where you can constantly update a model with new information, then all kinds of weird stuff is going to happen in our world. That's a barrier to so many possibilities when we think about like stuff like AGI and all that weirdness. That's the big one. So the question of like if the model was free and you could update it with new information, that would change a lot. And I don't know if we have answers on exactly how it would change things, but it would be pretty big.
Thank you for phoning in, Max.
Thanks, Max.
Thanks
Great
for
to see you,
inviting me.
man.
Oh, he's doing more than fun.
Good to see you. Enjoy Haystack. Later.
And now I want to ask your indulgence because I know all of you would like me to refuse the microphone to Stavros at this moment. He has been patiently waiting with his question, and I see the anticipation on his face. Stavros, they're going to give you a few minutes to get your answer. If Doug and Trey don't mind.
Sure thing.
Click streams. Clearly I love them. Why do I love them? Well, I've been working with my colleagues and working with Trey also on the book, making sure that user behavior insights data is available to people using the book. So I certainly am not against click streams. But we've been assuming in this discussion this model of query response, and we're refining it in some interesting ways. Like the response might give you some diversity, for example, so you can give a signal back explicitly to the engine. But what seems to be missing to me is we talk about conversational search, but that's not a conversation. That's a Q&A. And it seems to me that we ought to be looking more, as people get more accustomed to asking long questions, which is going to take a while. I mean, as you know, Alexa and so on did a pretty poor job in interpreting questions, so trained our users to give, just as the old search engines trained our users to make very short queries. It's going to take a while for users to start making longer queries. But then I would hope that we would move to true conversation. If you go to a clerk in a store and say, I want a shirt, they're not going to say, oh, here are 40 shirts that you might want to try. They might say, well, what are you looking for? Are you looking for something fancy? Are you looking for something expensive? Are you looking for linen? What exactly are you looking for? RAG, I would guess that with an appropriate search query and an appropriate prompt, you could get RAG to fit into a true conversational role, where the query is not, I say shirt, and it says, here are the best results for shirts, but the answer might be, hey, you know what? Actually, there are varieties of shirts, and there's some interesting criteria that you might want to attach to shirts. So ask the user a question about that.
Speaking of asking a question,
what's the question? How are we going to get there?
I feel like a lot of applications, at least RAG applications, do this. There's a bot, and like at Daydream, for example, if you just say, I want this general thing, we'll ask follow-on questions and refine a bit. What's interesting is I'm not sure people have fully cracked the nut in e-commerce yet. Maybe Daydream. Hopefully Daydream will be one of those. But it seems like e-commerce is an interesting space that I don't have a good answer to. People might have more thoughts on this. E-commerce is an interesting space where people seem to right now want to have a short query, get some results, refine. Oh, I don't like this, change this. And there's almost in e-commerce this like conscious refinement that people want to do. They want to sift through the shelves in a bit. Like when you go to a record store, you like going to the rock section and just poking through. You like feeling and seeing the things very quickly. And I sort of wonder if there's a different kind of experience there versus true conversation around information. I don't know if that's the reason, but I don't think there's any technical reason we can't do what you're talking about.
Yeah. I think what Doug said about RAG is right. I think in a lot of ways, RAG has developed because vector databases existed and people wanted to leverage them to build these workflows around them. I think in a lot of ways, the things that a lot of the RAG frameworks are doing and flows are doing are things that will ultimately come back into the search engine. But I also think the search engine is probably going to change drastically in terms of what it looks like in the future. It's not going to be one big monolithic index that has a set way of analyzing everything that comes in, but it's going to be more of a workflow type thing. And so, when that is supported, when you can actually go into OpenSearch, for example, and have all of these injection points where I can say, well, let me just insert an LLM right here to do this piece, and let me insert an adaptive piece here which can actually do this in a loop until it finds good results and evaluate them. I think once we have that stuff as a capability in our search engines, I think a lot of the RAG stuff can just move in. Whether that happens or whether the search engines become just one piece of retrieval that are used in different ways by these external flows, I'm not really sure which way it will go, probably some hybrid, but I think it requires thinking about accessing information and processing information and getting more context in a very different way, which is thinking of it as a flow, a workflow that has lots of dynamic loops and dependencies and ways to look for context until the answer is actually resolved. So I think the whole field is in a large experimentation mode right now to figure it out. Yep.
Thank you, Doug. Thank you, Trey. Let's thank our speakers.